Have you ever written a base class, but realized some methods don't actually make sense to implement yet? Like an animal class that has a speak method, but animals don't all speak the same way. That's exactly why abstract classes exist. In this video, you'll learn how abstract classes force child classes to do the work, prevent broken designs, and make your C# code way more professional. Let's start with the problem they solve. When you create a normal base class, you have to give every method an implementation. Even when that implementation doesn't make sense, you end up writing fake logic just to make the compiler happy. Abstract classes fix this. They let you say, this method must exist, but I won't define how it works. The child class must. What an abstract class is. An abstract class is a class that cannot be instantiated, is meant to be inherited, can contain abstract methods. Think of it as a template for other classes. It defines what must exist, not how everything works. Abstract methods. An abstract method has no body, must be overridden, forces child classes to implement it. This guarantees that every derived class provides its own logic. You get structure without fake behavior. Why this matters? In real applications, you want consistent APIs, predictable behavior, flexible implementation. Abstract classes give you all three. They prevent bad designs and make large systems easier to extend. Real-world example, payment system. Imagine a payment-based class. Every payment must have a process, method, but a credit card processes differently than PayPal. So you make process abstract. Each child class is forced to implement its own version. No missing logic, no forgotten overrides, no broken programs. Abstract versus virtual. Virtual means this method has a default implementation, but you can change it. Abstract means there is no implementation. You must provide one. Virtual is optional. Abstract is mandatory. Common beginner mistakes. You cannot create objects from abstract classes. They are not meant to exist on their own. They exist to define structure. Trying to use one directly will cause a compile error. And that's exactly the point. You now understand what abstract classes are, why they exist, how abstract methods work, how they enforce good design. If this helped, subscribe, share, and comment what topic you want next. Next, we'll cover interfaces, which are even stricter than abstract classes.